Good. So Fresenius Medical Care is a very honest company, and we do everything we do with integrity. And we even mention the safety of the products and services on this mission statement. So it's a really good topic to discuss. These are my disclosures. I'm an employee of Fresenius Medical Care. I will use some pictures for illustration that should not be construed as a recommendation or a preference. And not all the products may be available in your specific region. So let's start with a little quiz here. So you see two examples, two things you really do not want to see in your daily dialysis practice. These are two incidents that happen. They are real incidents. They happen really in dialysis clinics. And if you look at these pictures, you may ask yourself, are these results of technical failure or human error? And now I want to reveal what's behind it. So this picture here on the left-hand side, this was actually a fire inside a dialysis machine, a very dangerous situation after a short circuit on an electrical board. But this was not because the machine did something wrong. It is because the technical staff who was cleaning didn't follow the instructions, and water went into the housing of the machine and created this problem. So you can see there is very often a link between the technology and the human factor. If you look on the picture on the right-hand side, that's a typical blood spill because of a blood leak in the dialysis circuit. So here, the tube detached from the pump segment in the machine. This, you would say, is a technical problem. It's an issue that happened during the manufacturing of the bloodline. There was an error and the piece didn't hold. But one point I want to highlight here, this looks terrible, but we all know that a small amount of blood can create, a lot of drama. This was a relatively small blood loss because the safety mechanisms in the dialysis machine worked properly. So there was an immediate detection of that blood leak and the pump stopped. You see here the venous clamp. That clamp closes and stops the blood pump and prevents the blood leak from creating a substantial blood loss. So here the learning is, yes, there is always a residual risk. We can have issues, but there is also technology built into today's devices that help to reduce the risk if such a technical problem occurs. So today, all of you are very well educated, highly trained nephrologists. Your staff in the dialysis clinics is well trained. We have regulatory authorities like the FDA in the United States, NMPA in China, BSI in the United Kingdom. These authorities, they make sure that every device going to the market has passed certain tests for safety and effectiveness. So why do we still see incidents related to dialysis devices? And it follows a very simple principle. Everything in life has a risk. There is nothing we do on a daily basis which doesn't have a risk. And even if we do everything we can to reduce this risk, very often there is a tiny little bit of risk that we just can't control. That is something we have to accept. That's called the residual risk. And this residual risk is in everything we do. Every day you cross the road, every day you play sports, there's always a risk, even if you're protected and you take care. So we try as a manufacturer of these products to reduce the technical risk as much as possible with all these safety mechanisms you will see in a minute, but there is a certain residual risk we have to accept. But the far bigger risk is the risk from error. So error is something which occurs because either of a technical failure. It could be that you have a faulty part in your dialysis machine. One of the pumps or one of the O-rings is faulty. So that's a technical failure that can lead to a problem. But there is also the so-called human or user error. That means the technology part, the device, actually works as it's supposed to work, but because of incorrect operation, you can create a problem. Now look at this dramatic example on the right-hand side. This is an article from about 10 years ago. It happened in the United States, where a patient died, and the article says after a faulty dialysis machine pumps a lot of liquid into the patient. So this is definitely something that appears immediately as a technical failure. But if you read through the article, you see that actually the nurse had been aware that the machine is faulty, but she has still used the machine during the waiting period for the technician. So it is very important for you all to understand that it is very often a combination of technical error and human error that leads to a major problem. So what do we do to reduce this risk? The risk, what we do from the manufacturing side, is we make sure that we transfer as much knowledge that went into the construction of a dialysis device goes to the customer or to the end user, which is the nurse or the doctors. And this is our responsibility to make sure that we transfer this information to you. This is not just something we think is good, it's actually a legal requirement by many of the regulators. So for example, many of our machines carry a CE mark. The CE mark is the regulatory approval for Europe. And if you manufacture your device in Europe, it is a legal requirement that wherever in the world you distribute, that you bring this knowledge to the end user to reduce the risk. So a lot of this information is in the IFU. And the IFU is something that many of you see, but I'm not sure how many people read it, because it's usually a very thick book. Today it doesn't come as a book. Today it comes as an app on that you can read on the computer or the iPhone. And I can see many of you looking at their iPhones. Maybe you're all checking the IFUs at the moment, which is good. But this is only one piece. Yeah, it's a lot of written information, but the more important part is what we call the clinical application training. So that means whenever you get a new device, you should work with the manufacturer or the distributor of the device to ensure there is knowledge transfer. You should talk through the device with them. You should train and practice how to operate the device. You should discuss troubleshooting. This is very, very essential. And this is one of the most important factors to reduce error. And there is enough evidence to show that good training, and the most important part is repetitive training, not just train once and then think everything goes. Do repetitive training. And you can see here from a couple of examples from recent studies that you can reduce the risk for error and adverse events if you have proper training programs. There is also an aspect on the patient side. We have learned that well-educated patients also reduce the risk of error because they can make the doctor or the nurse alert if they make an observation which could have an impact. And you see here is data from our own clinics. You know, Fresenius Medical Care operates a huge number of dialysis clinics around the world. So we did a program where we educated patients over a year-long period, and then we measured certain incidents. And you could see that the reduction within 1 year was quite significant as an effect of this training program. Now, let's talk a little bit about what the research and development teams of the providers of these dialysis machines do to make the devices safer. And I hope that you now look all on the screen of the presentation and not at your mobile phones, because this is really important for everybody who operates dialysis devices. Yeah. So these machines, and I just take one example, there are many of dialysis machines in your country, and it's just one example that I'm very familiar with, which is a machine called 4008S. So there are different alarm types, and I will talk about these different alarm types, and depending on alarm type, there is a different process. So some alarms, they just sound and give you information that you need to prepare for something or that you need to be alert. And some alarms trigger an automatic reaction of the machine. For example, they close the venous clamp and stop the blood pump. So this is important that you understand the different types of alarms. The most important set of alarms are the alarms around the blood circuit, the part of the machine that carries the patient's blood. And here you have different alarms. Some of them are pressure alarms, the typical alarms, and every dialysis nurse knows them because these are the most annoying ones, are the pressure alarms on the venous and the arterial line. The pressures in these lines are continuously measured, and they have very, very important information for you and are important for the safety that you look at this. And then there are some other alarms, for example, one, and as you know, this is also a life-saving alarm, detection of air in the blood circuit. That is absolutely a necessary reaction to stop the blood flow, and some others. There's another set of alarms, which are the hydraulic alarms. The hydraulic alarms are the alarms on the side of the where the dialysis fluid, or in hemodiafiltration, the substitution fluid is processed. They are very different from the alarms on the blood side. They may be not as critical, but they are still very important to steer the treatment, to control the treatment in a most efficient way. And in the future, some of the next features that will come with dialysis machines will use some of these elements to actually automatically stabilize the patient on dialysis. For example, conductivity alarm, the conductivity system controls the electrolyte concentration in your dialysate and also in the patient's serum. So there are interesting things coming up looking at this, but these alarms are on the side of the dialysate. And then you have some warnings which are related to other parts of the machine operation. There is, for example, every machine does a regular test, the so-called cyclic pressure holding test. And during this test, you need to be aware that this test is going on because certain things are stopped during this short period. So now let's take an example. Yeah, it is always good to learn from example. And one of the most feared complications in dialysis is the venous needle dislodgement. And we want to talk a little bit how technology can help if you do this properly. So everybody knows that once the venous needle dislodges from the patient's access and the machine doesn't stop, it pumps patient's blood right into the environment. It's a process of exsanguination, and the patient will die if you don't stop them. Therefore, the venous pressure alarm is, I think, one of the most important alarms that you need to set on your machine. If you don't set the venous pressure alarms properly, your main control for venous needle dislodgement is gone. You also need to check that the alarms are activated, because you can mute certain alarms, but if they're muted, they cannot alert you. Now, a very practical but very important measure is to set venous pressure alarms asymmetrically. This is something you learn best during the application trainings with the people who have developed these devices to tell you exactly how to do that. You can see here on that little insert where you see the venous pressure alarm, and you see that the error window is the orange part and the green line is on the bottom. The green line, the actual venous pressure is very close to the low alarm limit of the venous pressure alarm. Not so close to the high, but very close to the low. So if there is a little change of venous pressure downwards, reduction of venous pressure, you get an alarm. This is a very, very handy concept that we have seen helps a lot in managing venous needle dislodgement. Newer devices have built-in technology who, on top of these standard venous pressure alarms, which work in a rather wide pressure window, they can actually detect pressure drops earlier, not just by absolute measurements, but by contour analysis of the pressure curve. For example, one device is the venous access monitor that can detect pressure drops as low as 15 millimeters mercury. And then you also have some external add-on devices, as you see here. These devices you can attach to the dialysis patient. For example, this little sticker goes around the venous access. If that sticker detects wetness, you get a very loud alarm, and that wetness can be blood when the venous needle is lodged. So you see, there is a lot of technology that can help handling safety on the patient's end. But I want to give you here a short case study, which is from a real case where we looked at what the machine records. The modern dialysis machines, they can record a lot of data, and if there is really a problem, you can analyze what happens. And this is very common. You see here, all the reds are alarms, yeah? And at the beginning of the treatment, there were lots of alarms. And what is the natural reflex of many people in a dialysis unit when there is an alarm? The first thing is you quit, you reset the alarm, and you start the machine again. And you can see there is very, very little time between these alarm and the reset. So very often there is actually it's very hard to believe that somebody actually really looked at the patient. Yeah, so very often it is something where you just see alarm and then you quit. And that went on for a little while, and then you see something very risky, which happened here at some moment, because the alarms came in a rapid sequence. Somebody decided to reset the alarm limits. And that actually then led to a situation where the patient lost 1.5 liters of blood because of a venous needle dislodgement. Here's what I'm talking about. Initially, the initial setting was the venous pressure was around 95. So the alarm setting was at 80, the low alarm setting, which is good. It's very close to the actual venous pressure. So this is what I call asymmetric alarm setting. But because the operator got annoyed, then that person changed the alarm window, and she set the lower alarm window down to 55 millimeters hemoglobin, mercury. So you could see that then it took a much longer time to actually detect a pressure drop. And so there was quite a time, and the patient lost 1.5 liters before this was detected. So you see, it is very important that you combine technology and your common sense to make the operation safe. The alarm, when you have a venous pressure alarm, a lower venous pressure alarm, you can see here that this is very often, there are many causes for this, as you can see here, from, of course, needle dislodgement, but it can also be a clotted dialyzer, or it can be a wet transducer protector, the piece that measures the transducer, translates the pressure to the sensing device. If this gets wet, you can get accurate measures. So the first thing you have this alarm is not to reset your alarm, is to look at your patient to make sure that all these things are in order and that there is no problem, and then you can adjust as needed. And as you can see, there are various ways how you can correct low venous pressures, as you see here in the green box, and that's what you then do. So the key takeaway message here is the HD machine is a monitor at the moment. Yeah, and the information that is displayed there is for you to take the appropriate action. It is your responsibility as the operator to make sure that there is a synchronization between the machine advice and your action. I found this funny quote, which I think fits quite nicely. It says, the machine doesn't come with a brain, you still need to use your own one. In the future, we may see so-called closed loop systems. They are under development, they're in testing, where basically once a dialysis machine sees an issue, an alarm, it triggers a change in the setup. It triggers a change in the configuration of the machine to resolve this. But this is something that we will see in the very near future. Today, we have to make sure that if there's an alarm, we deal with the alarm. So to summarize this part, most errors in the hemodialysis world are human errors, and they can be related to processes that we have not designed properly. It can be something where we didn't do proper education. It can sometimes be just the situation. Look at these three pictures that I brought to you here. This is a very common picture. Many dialysis units have more than one machine type. And if you have more than one machine type, you need to be trained and you need to maintain your knowledge on different machine types, because these machine types sometimes have different ways how they operate and require different actions. So that's a situational issue where you need to have a process. what we see at the moment all over the world is a substantial burnout of our nurses, not just in the ICU, everywhere. So nurses are very stressed, the workload is very high, and the more stress you have, the less you can concentrate. So this is also something we need to see how we address this. And one good way of addressing these things is what you see here at the bottom. If there is a problem, sit together, analyze the problem and discuss it as a group. And then we can see what improvements we can make in terms of the process. Maybe it's really a technical issue. We need to call in the technical guys. We need to inform the manufacturer. So that is very important that this is discussed. I want to also suggest to you that you introduce the category of the so-called near misses. So let's say there is a mistake, but you spot it or your colleague spots it and said, hey, be careful, please correct this. Nothing happens. But you have already discovered the weak point. So this is a near miss. Nothing happened, but it could have happened. So this is a point which is very good to bring to the group and discuss. Said, well, this morning, I almost took the wrong size of syringe that I attached to the heparin line. Yeah. So this is something which is a near miss. And then you say, well, let's look at our process. If there is a process step, check appropriate size. Yeah. This type of thing is very important. And I think we have very good experience with this so-called near miss category, where we make sure that we discuss this as a group. Include the patient, a patient who comes 2 or 3 times a week to dialysis, they know a lot about their process. If they observe something funny, encourage them to report this to you so that you can check and then take a decision. Let me mention 1 minute about one important aspect, which is often forgotten, which is the medical device lifecycle management. If you buy a dialysis device or any medical device, it's not done once you buy it and you put it into your operations. Every mechanical device in the world, everything, a car, a mobile phone, television set, dialysis machine, everything that has mechanical parts has wear and tear. So it is very important that we look at these, because as part, for example, as the service offerings that the manufacturers provide, certain parts are replaced on a regular basis. If you don't do this, they can fail. This is part of the process. For example, you see this blue tray, these so-called O-rings. They can wear off over time, so they need to be replaced on a regular basis. That's an important part, and it needs to be considered that you don't stop maintaining your device. Make sure that the people who take care of your device are qualified and certified by the manufacturer, because as I said, there are many, many types of dialysis machines and many are very good, but you need to have the individual knowledge for every device. And one thing I can only warn everybody is if you try to do self-service. So we've seen this many times that, like the house technician who has never been trained, or sometimes even the doctors, they try to open and make some changes on the dialysis machine. This is very dangerous because of 2 reasons. First of all, once you do this, your warranty immediately is invalidated. Yeah, because then the manufacturer cannot control what happened to the machine. But even more, you can do things that are dangerous for the staff and for the patient. Look at this picture here on the right-hand side. That's something I found in the dialysis unit, not in Vietnam, but also here in Asia, where in this area, there should be a water filter. Yeah, a water filter who, if you listen to the previous talk, you know exactly how this should work. This machine, this filter should make sure that the dialysate is ultra pure. But here, this water filter has been bypassed. So this is a very dangerous setting, and I just want to let you know that when you look at cost, a lot of these things are happening for cost reasons. You should not just look at cost of the individual item, but you should look at the total cost of ownership. If you compare the cost of the replacement of a spare part or repair or technical service to the cost of a major incident in your unit, I think that is something that speaks for itself. So it's very important that you consider and discuss and organize the technical service of your medical device. Okay, now we've heard a lot, and now before we end, I want to do a quick, test with you. We cannot be very interactive here, but take a minute and look at this picture and tell me if everything is okay, or if you can spot any problem, technical problem or human error. Okay, I'm sure you're all experienced people, you've all spotted it. Now let's go through it. It's actually quite a number of things. So one thing you can see here is this, and this is one of the biggest issues you can have. Somebody did not put the line through the optical detector and the venous gland. So basically your main security mechanism is bypassed. And you can see there is blood running through the machine. So this is not a fake picture. This is a real picture that I found during one of my many dialysis systems. So if you have now air in your system, it cannot be, the safety mechanism cannot be activated because the line cannot be clamped by the machine. The other issue is that there is the optical detector who detects blood in the circuit is also here in this setting. If the machine cannot detect blood, it will not start the treatment. So in this machine, you see here, it is still in preparation mode. So when you're in preparation mode, all your alarms are deactivated. Look at this here. All the alarm triggers are on the upper and lower ends. That means they are not set, they are not active. So this machine is like, you know, flying blind, no control whatsoever. And the other problem is, of course, here, if you do not activate the treatment, if the machine runs in preparation mode, there's no dialysate flow. So there is no dialysis going on. So you can see a little error on this setting can create a lot of problems. Yeah, so be very mindful that this clinical education of everybody who uses these machines is in place, and that people follow the guidelines and the recommendations quite strictly. A little bit like when you start an airplane, you know, you have a checklist, and this is a very good concept to introduce here, make things happen. Just a couple of other observations here. No arterial pressure monitoring. Yeah. I think personally arterial pressure monitoring is very important, especially in people who have not so good fistulas, because you really know what's going on in your fistula. Yeah, not connected. And if you look here, you can also see it here on the insert. There's blood coming back along the heparin line. That is always a sign that the syringe that you use is not approved for this machine. So these are all things you want to take note of. So we are almost at the end. So my take-home message to you for today is most errors are the result of human errors. It's not you, it's us. Every human being makes errors. Technical errors are less common. But with good training, good education, repetitive education, and an open dialogue around errors, you can actually prevent most of the human errors. The manufacturers, we take the responsibility to reduce the technical risk as much as we can. That's why I showed you all these safety features that are in the machines. But it's also the operator who needs to have good processes in place to make sure that the operation of the machine is safe. If there is a suspected technical issue, and I showed you examples, something can go wrong, let the manufacturer know. It is very important that you report this. Report it through the mandatory channels. It can be the regulators, health authorities, but also inform the manufacturer, because we can only get better if we know where we are weak. So please make sure. Safe and effective function of the dialysis machine requires a quality product, but it also requires regular maintenance. And it also requires that you pay attention if people explain things to you. Yeah, this is very difficult in the times of mobile devices, because everybody likes much more to check what's going on Facebook. But it is very important that you pay attention and that you're alert when we do this kind of education series, and always consider the total cost of ownership. So I want to end with this very nice quote from Kevin Collins, who was a 100-meter world champion 20 years ago. He said, strive for continuous improvement, not always for perfection. And I think that's a very important statement, that we need to make sure we look at what we're doing every day, we look at the technology and the human factor, and we bring it together. So with this little picture of Vietnam, I want to end my session. I'm a great friend of coffee, and my favorite coffee is the coffee in Vietnam. And as you're all nephrologists, I know that coffee has good things for the kidneys. So I hope next time I will get a chance to meet many of you over a coffee in Vietnam. Thank you very much for your attention, and have a wonderful conference.